So our agenda for today, we're going to give you a little bit of a background on the School of Data Science, give you a chance to meet our faculty members on the call, get you a chance to meet your admission ambassadors who are here to serve as a resource for you to give you information about the program, and then also have opportunity to meet with them outside of this call to ask them what it's like to be a student in the program. These are all online Masters in Data Science students. But we also have ambassadors for the residential program if you're more interested in that one. Then we'll give a program overview. We'll talk about what it takes to apply to the program. And then you'll get a really good chance to see some projects that the ambassadors have worked on in the past in the program, so you can get a sense of what you're going to learn in the courses you'll take. Then we'll talk a bit about career services and outcomes. And those things will get to a lot of the questions I've seen in the chat so far. And then we'll have some time for a Q&A at the end. And as I said, you can drop any questions you have in the chat. We want you to engage and ask your questions because this is your chance to learn a lot about the program, and we're here to answer any questions you have. But if you do have something that's very personal question, like a specific prerequisite or a GPA requirement or something like that, please reach out to me. You have my email. I've been the one sending you out information, but it's also here on the slide. And we can set up a time to meet, or we can talk through email. All right. So people on this call, as I said, we've got Professor Alvarado. He is the residential MSDS program director and associate professor of data science. I don't know if Professor Tashman is popped on, but he should be coming. And he is the online MSDS program director, and he's the associate professor of data science as well. And then myself, I'm the assistant director of graduate admissions. And then we've got 4 of our student ambassadors on the call: Brago, Chelsea, Holden, and Emma. All right, so our school, just to give you a bit of background on where we come from, we call ourselves a school without walls because although our new building shown there will have walls, we are a school without walls in the sense that we're purposely interdisciplinary. And you'll get a sense from listening to the backgrounds of our ambassadors as well as our faculty members that people in our program, they come from everywhere. They come from the humanities, they come from STEM, they come from the social sciences, sometimes music, sometimes art, a whole range of backgrounds. And the goal is that our school brings together people who really come from any discipline, but want to use data and data analytic tools to inform their research and answer really challenging questions. And so that's kind of a bit about why our school exists. We're not very specific like many schools and programs in data science where we're in really one field, like say business analytics or bioinformatics or something like that. We're broader, and we give students the tools that they need to succeed in any field where they want to use massive amounts of data, be able to model that data and learn from it. So a bit about where our school is right now. We've got two master's programs. One is a full-time 11-month master's in data science, and that's the one Professor Alvarado is the program director of. And then we also have an online master's in data science that's part-time, it's 5 semesters. We're going to focus a bit more on that in this call. But we'll also talk a bit about the full-time program as well. We do have some dual degree programs because of our interdisciplinary focus with the Darden School of Business, the Graduate School of Arts and Sciences, the School of Medicine, and the School of Nursing. We launched an undergraduate minor. We have a lot of students in that program. We're working on creating a PhD program. We're going to launch an undergraduate major soon. We're really expanding our faculty. We have a data activist in residence. And really our school is just kind of booming. And so this is a very exciting place to be for all of us who work at the school, but also for you as potential students to be part of a really expanding and evolving effort. All right, so enough from me. I'm going to give Professor Alvarado first a chance to introduce himself and give just about a 2 to 3 minute background of what classes he teaches, how industry experience and his research in particular applies to his teaching, and how it applies to teaching of other professors in the program, and then any general advice you have for students who are considering applying.
Here we go. Yeah, thank you for that. Let me just be real quick about this. I'll just follow the rubric that you have here. So yeah, well, yeah, my name's Rafael Alvarado. I'm the program director, but I'm also I've been with the School of Data Science pretty much since the beginning. I have a kind of an interesting background. My background is actually in cultural anthropology. I have been a career digital humanist, and I transitioned to data science about 6 years ago. And I was able to leverage some of my undergraduate engineering education to fill in some of the gaps in some of the quantitative stuff. So what I actually do is I teach, I'm a capstone advisor teaching both online and offline cohorts in the capstone experience, which if you haven't heard of it, it's a fundamental part of our program, which we're going to talk about a little bit more later. I also teach a course called Practice and Application of Data Science 6001, which is really focusing on the pipeline, getting you from the point of data acquisition, acquiring data in a variety of ways, web scraping and that sort of thing, and shaping it until you can have it in analytical form and do things like exploratory data analysis and basic statistics and understanding what your data is capable of downstream when you do more sophisticated analytic stuff on it. A course that I've created specifically for this program and as an elective is something I call exploratory text analytics. And that is basically applying what are called unsupervised methods applied to long form texts to uncover historical and cultural patterns in those texts. And so what long form texts are things like novels or newspapers or collections of letters, things like that, as opposed to short form stuff, which is like tweets or maybe like blurbs in a database that might have some useful information. So the course focuses on that, and it has two sorts of values. One is that it'll help you understand just the general process of working with text, which is often called unstructured data. Super important part of data science. It's kind of one of the distinguishing features of data science working with text is just commonplace in a lot of the projects you'll work on. You'll be introduced to a lot of methods that'll either reinforce things you've learned in other classes or introduce new things. Such as TF-IDF, principal component analysis, being able to measure similarity and distance in vector space, topic modeling, word embedding, sentiment analysis, language models, and things like that. So really the course fills in a gap, an important gap in the program, if you're interested in going in this direction for NLP. There are other courses that the university offers that take different angles, like in computer science. But this one is really sort of unique because it focuses on the long form text. And it also, I think it's super important that that if you're going to work with text, that you bring domain knowledge into your understanding of what a text is. A lot of times that's missing. And when people are working with textual information, there's a long tradition of scholarship, literary criticism and structural anthropology that helps us understand the nature of a text and how you can sort of deconstruct it and structure, extract cultural patterns from it. That's a big part of what the course is. So in terms of my industry experience, as I said earlier, I come from, it's within the academy. I come from digital humanities background, and I spent a lot of time building pretty large digital collections of texts and images as well from different cultural traditions and different working with different authors. So I've built a Persian database of the text, the Shahnameh, and all of the images associated with that text. I've worked with old French collections of text, Hebrew, works of Dante, works of Faulkner, and that sort of thing. And these are all digital collections that require understanding the structure of text as a data format, and also how you can deconstruct that text into tabular form and do other sorts of things with it. In terms of my own research, so I'm actually right now, I just got an NSF grant to build and collaborate with a professor in Spanish to build a digital collection of Mayan texts, so and Mesoamerican texts in general from the colonial period and the pre-colonial period to build an indigenous collection of texts, which is a really interesting area to go in. And that's actually consistent with my degree. I wrote my dissertation on classic Mayan kingship as can be understood through their hieroglyphs. So there's a lot to say there. So let me just stop there, just give you guys my take on general advice. I just have two things. There are a lot of things one could say here, but one is, you probably are already thinking this, but it's taking the prereqs seriously. Not that you're not taking them seriously, but really, if you feel like you might be a little rusty and you have your prereqs sort of formally defined as checked off, maybe go back and brush up a little, like on linear algebra in particular and programming. If you have experience with programming, keep it up, and try to find projects on your spare time to do. If you don't have experience, or you feel like you haven't had a lot of experience, it's always a good idea just to do something sort of like on a daily or weekly basis. Just find a problem to work on. Just keep at that, because coding is like, the analogy we use here is like learning to code, and coding in general is like playing a musical instrument. It just takes practice. It's the kind of thing that you may feel like you're frustrated one day and you don't understand something, and the next day you understand it. And it's also kind of, there's a muscle memory dimension to it that is important. So you just kind of build up the habit for it. It's really important to be successful in the program, to have a comfort level with the coding. And that's pretty much, that's my big piece of advice really, is develop your coding skills as much as possible. There's a bunch of other stuff one could point to as well, but that I think is probably one important takeaway. So I'll just leave it at that, and we can, talk more about other things in the Q&A.
Thanks, Professor Alvarado. So that's great advice. I don't think Professor Tashman's here, but yes, he brought up a good point. Definitely take the prereqs and the programming seriously. And what you get from his background is the sense that it's really true that students come from a whole range of backgrounds, just like faculty. He's in the languages, and in text. That's very different than what you might think in a typical STEM background. So he illustrates that really well. So it's time for ambassadors to introduce themselves. So just they will get a sense too of where they come from, and different student profiles of people who are in the program, and be listening to for if there's a student ambassador that you really relate to. I'll be sending out a link after this to sign up to meet with them. So this would give you a chance to find someone that you think would be a great fit to talk to, who might be from a similar background, and then you can have a chance to meet with them and learn more about their experience in the program. So I'll just start with Holden. I see you on the top of the screen.
All right. Hi, everyone. My name is Holden. I studied economics during my undergraduate. And the school I went to, I went to Brown and studied econ there. And it was definitely a data science focused undergraduate experience, which I think was a good primer for me being interested in the different applications of data science and ML. So after graduating, I worked for a financial technology startup. And after 2 years, wanted to go back, get a master's. And I didn't really know whether I wanted to end up wanting to go to like a large company after graduation, or just basically go to a small place and have the ability to be like a self-sustained data scientist. But I'm about to wrap up my program, and I've joined a startup, which is awesome because it's a good indication that I actually have learned an incredible amount during the program, enough so to like actually start tackling problems on my own. So I'd say that was one of the things I was looking for in this program. And one of the things I think really sets UVA apart is that it gives you the resources to do whatever you want and achieve whatever you want from an educational perspective. So I really appreciate that.
Awesome. Thanks, Holden. Emma.
Hello. Apologies for my camera being off. I've been having a lot of technical difficulties today, but I graduated from UVA with a bachelor's in commerce and computer science, and I currently spend my time as a software engineer for a small government contractor, and kind of similar where I was observing a lot of my colleagues who do a lot of work with data science in the department, and I kind of just rather do what they'd be doing. So I came to this program.
Thanks, Emma. Chelsea, I see you up next.
Hi, my name is Chelsea Alvarado. So my background, I studied psychology in undergrad at Sweetbriar College. And then I kind of had this weird path where I went from like hands-on, like mental health work to research on fruit fly brains, which is where I discovered my interest in data science. And then I just recently started a position as a contractor doing research on Alzheimer's disease for the NIH. Yeah, really excited.
So thank you, Chelsea. So she illustrates too that you don't necessarily have to have a STEM background to come to our program to do really well in it. A lot of people have an interest in data science that just kind of comes up by doing something else and learning that they really want to practice and want to learn how to do data science. So our program has a lot of those students, like Chelsea as well. So last person, Brago.
Hi, everyone. My name is Brago. I went to UBA for undergrad, studied math and statistics, and I'm currently working as an analyst at a data science company. And I decided to do the MSDS program because I knew I wanted to learn more about data science, not necessarily just from a work perspective, but from an educational one also. And I did the online program specifically because I wanted to be able to balance working full time while also being in school.
Yep. Thanks, Brago. All right. So that's a sense of our ambassadors. We will also have a chance for you to ask them and Professor Alvarado any questions you have at the end of the overview. But right now we'll talk a bit about the program itself. So our curriculum is designed to give you the ability to work with diverse, meaning lots of different forms and very large data sets in the several millions. And as Professor Alvarado mentioned, not just numbers, but also text, and really any form of data. And it gives you the ability to work with leading platforms and coding languages like GitHub, Python, Spark, next to each other in the alphabet, SQL, and Tableau. You get the knowledge of modeling concepts and practices, and you also get the confidence to communicate findings to stakeholders and the ability to work productively in a team environment. So it really gives you the skills you need to work from all aspects of the data pipeline, from collecting data, scraping data, cleaning it, all the way through to presenting it, modeling it, and iterating. So a bit about our program. We have 4 prerequisite courses. One is single variable calculus. Second one is linear algebra, and we do offer a 8-week boot camp for linear algebra that you can take through us. It counts for the prereq. You can find it on our website. Introduction to statistics, introduction to programming. Those are the 4 main prereqs, and we are GRE optional. And by GRE optional, we are really GRE optional. Like, we don't flag applicants who don't put in a GRE score. If you want to put in a GRE score, you're more than welcome to. Cases that we might recommend is if you feel maybe like your undergraduate GPA was a little bit lower than you had hoped, and you think the GRE score could really complement that, that might be a reason to put it in, but it's definitely not required. So for the online program, it's 5 semesters long, operating over the summer, the spring, and the fall. It's 32 credits in total, comprised of 12 courses, and it's a flipped classroom schedule, meaning that you are practicing in class and learning outside of class. And some unique characteristics of the program: it is a rigorous and lockstep technical degree, which means you move through with a cohort, and you progress from one class to the other together. You don't take classes out of order. One really unique characteristic that Professor Alvarado and our students can talk more about too is our emphasis on ethics and values. And that is built into every class that we teach, as well as having its own standalone course. That's something that makes us unique relative to other programs. We focus on not just how to use data, but should you use it and in what cases, and how can you do it ethically. We focus on an active learning style. It's not theoretical, meaning that you're not just learning like math theorems and theorems of computer science, you're really practicing them. And it's all focused on things that you can use in your job on day one. Our faculty come from across industry and really represent about any background you could think of. But they also, are very like practitioners in of themselves. And so they can give you the skills that you need to succeed in industry. And then we're a small cohort community. comprise of around 50 graduate students. And even though it's an online program, the ambassadors can tell you more about it too. It really does feel like a unique and really tight-knit group, because you're doing a lot of your projects, most of your projects in groups, and you're really getting a chance to know each other and work together. So I'll let Brago talk a bit about the curriculum and electives.
So for each semester, we take 6 or 7 credits, six for the first 3, and then 7 for the last 2. The courses are, generally speaking, obviously related to data science, but using data science in different aspects. So the first 2 are programming for data science, where it really start using, I think for this class, Python is the primary programming language. Doing that, working with linear models. And towards the end of the program is where we start taking electives and working on our Capstone project, where the capstone is the big end of program course / project. And at a quick overview of the 3 electives that are offered. We have, the first one is exploratory text analytics. The second is big data systems. And the last one is business analytics for data scientists. All 3 of these classes use programming and data science techniques for different aspects of, to showcase how you can use data science in different aspects of the industry, or your career wise.
Cool. Thanks, Brago. And we'll have a chance to, at the end, when you ask questions, you can ask more questions about specific parts of the curriculum as well. We also offer a capstone project. That's the big thing you're working on in semesters 4 and 5. Our ambassadors are also happy to answer questions about that. But some highlights about the capstone project is it's a collaborative group project. It's focused on real world application. You are working with an actual company, an actual organization to solve a real data science problem. We got people working with NASA. We have people working with the Department of Education. We have people working with particle physicists. We've got a whole range of projects that students are working on. And they're all real problems that are happening in an industry. And you're working in a group of at least 2, but sometimes up to 5 of your classmates. It's multi-term, meaning you're doing it in 2 different terms. It's experiential in that you are working throughout the whole data science pipeline that you learn about in class. And then this really helps program graduates become well-rounded and really have some great hands-on experience working in data science. And so if you're someone who might not have a huge background in data science, this is a great way to put a really awesome project on your resume. And if you're someone who has experience, this is just another thing to add to projects you've worked on. And it's a really practical way to present yourself in a technical interview and be able to talk about how you solved a real world problem. So a bit about the admission process and student profiles. I'm going to move pretty quick through this part just because I want to save time for the Q&A and for you to hear from our ambassadors about different projects that they've worked on, because that's really the best way you'll get a sense of what the program's like. But if you have questions, we can also talk through them at the end. So some skills that students need to succeed in our program. You have to love solving problems. We do require you have some working knowledge of math and statistical concepts and a high level of quantitative ability. Proficient at programming. These things are picked up in the prerequisite courses. You have to be able to communicate and you have to love data, or else this doesn't make any sense for you. We are the School of Data Science. So where do students come from? This applies to both the online, also as the residential. Many people come to our program as career switchers. So people like Chelsea, who started off in kind of a psychology career and then moved into data science. Professionals in the STEM field who want a promotion, people who just love to code, recent college graduates who are working full-time and want an advanced degree. So that's like Brago. Leaders with terminal degrees who want to master data science tools. So we have a lot of doctors and practitioners come to our program who want to use data science in their medical practice and want to understand how to use those tools. And so this is a program for people like that as well. And then people like Emma, who work in government and want to use data in their work. So students come from a full range of backgrounds. I'm not going to read them all, but that's a pretty comprehensive list, although we probably missed a bunch of them because people come from really everywhere. So you can come to this program from almost any undergraduate background, as long as you complete the prerequisites. So the application itself requires a statement of purpose. That is critical in helping us understand why you want to do data science. So definitely take that part seriously on the application. Some short answers, including a question where you can talk about all of your formal or informal coding experience. That one is extremely important as well, especially if you're someone who maybe hasn't worked in a data science job or maybe doesn't have a ton of coding classes under their belt. If you've done coding projects, we want to hear about them. And those are things that we consider heavily in the review process. We are GRE optional. You need to upload a resume, an unofficial transcript. You submit the official one if you're accepted into the program. We do have a 3.0 minimum GPA. With that being said, though, if you are close to that and you want to make your case to our committee, you are more than welcome to submit your application. But we do require a minimum GPA 3.0. 2 references, one of which we want to be someone who knows you academically. If you're someone who's not been in college for a long time, several years, and there's someone who you work with that can speak to your academic capabilities, that's fine too. But if you're a recent college graduate and there's a professor who you really connected with, that's a great person to have submit a reference on your behalf. Our prerequisites are here. They're on our website. We accept community college courses, so you can find an affordable alternative to taking it at a 4-year institution. And we do accept online courses, but they have to be for a college credit, and there has to be some kind of grade associated with it. It can't be a non-credit MOOC or a class where we really don't get a sense of your mastery of the material. All right, so key dates for spring 22 entry. So November 19th is the final deadline. December 10th, we'll release the decisions. We'll have an admitted students webinar on the 14th, and then a decision and deposit deadline on the 17th. Note, we are skipping a summer term this year. So the next cohort won't be admitted until fall 2022 with a deadline of July 15th. That's because we're working on creating a pipeline for students who are more interested in data engineering than working as a data scientist. So we're taking a pause on our summer term for this year. So if you want to get an application in before next fall, now is the time to do so. Okay, so without more of that, we're on to some project examples from students who are in the program. And they provided some workload estimates for each class, but these are based on their experiences. And you can kind of get a sense of where you might fall in that based on their estimates for how much time they spent in these courses. The goal is to really give you a sense of what it's like in the program. So without further ado, I'll turn it over to them and really Holden and Chelsea brag on your projects and let people know how cool the work that they'll do in the classes is.
All right, so this was actually the first project, like major project that I did in the program. So one of the cool defining features of UVA's approach to the master's program for data science is that you have homeworks and problem sets, of course, but at the end of every semester for every class, you have one large assignment that you're supposed to apply everything that you've learned over the course of the semester to some coding project of your choice, typically. So for this one, we were supposed to do something with web scraping. And I thought it would be fun to pull in all of the information from I found online that had basically like all of the transcripts for the different Rick and Morty episodes. And then, so built a web scraper for that, and then built like a pretty rudimentary, because it was my first semester, but the machine learning model to learn the general tone of each character, and then generate like a new speech or a new scene between like Rick and Morty. so that was super fun. It was kind of hard, but it taught me a lot about ETA, a lot of the things that will set up success for later on in future semesters. So that was just like a really fun project that I got to do early on in the program.
I think it got out of order, but I'll go ahead because this is my slide. So this was my final project for the exploratory text analytics class. So basically over the course of the semester, you learn all these different methods of how to apply unsupervised learning to different texts. And so what I decided to do was to grab 8 banned books that I found really interesting. And I've also read in the past, and I wanted to see, I was like, is there truly one common factor that these all share? Or is it, what's keeping all of these together as banned books? So essentially what I ended up finding was that there is not necessarily like one common factor. Like they don't share like a phrase or even a topic that makes them banned, but instead what they share in common is that they kind of all cluster together into controversial topics. So here I have a few examples of a hierarchy cluster diagram and then principal component analysis. So here you can see that in the top 3 corner, I have like The Handmaid's Tale, Catcher in the Rye, and Song of Solomon. And these 3 books clustered based on what I interpreted as like highly sexual content. And then you get Animal Farm, 1984, and The Jungle, which have a political undertone. Well, they are political. And then in the middle, you get Harry Potter and To Kill a Mockingbird, which were kind of like the more difficult ones to classify. But basically, I concluded that it was like coming of age was the best way to put it. But yeah, that's what I ended up doing for that project. And I definitely spent quite a bit of time on this class, but I really enjoyed it because as someone who didn't have a Python background, this class actually helped me like improve my Python a lot.
Cool project. I like that one.
Yeah, that's pretty awesome. Did I skip a slide, Chelsea? No, I didn't. Okay.
So this one was the last major project that I did. And I'd say probably I don't know, it was one of the more interesting projects I've done, potentially like my favorite. So this was for the class where we were exploring very large data sets and coding in an extension of Python called like PySpark. It's like basically a way to use something that's kind of like Python to work with really, really large data sets in a more efficient way. So for this project, what I did is pulled in data that had been collected by New York City. And it was on house code violations. So first of all, I live in New York, I live in Brooklyn, and like, if you have a problem with your house, you can call 311 and it will submit a report to the state of New York. And all of that is tracked and has been tracked for about 14 years. And what we did is we pulled in every single complaint, which is millions and millions and millions of complaints, and then ran a series of analyses on those complaints. So the reason why I enjoyed this so much is it was difficult to deal with such a massive data set. There were just like, you ran into some challenges that I hadn't experienced with my previous Python projects. But more importantly, I'd say, is the conclusions that we found were pretty striking. So what we ended up doing is trying to see how many housing code violations there were, and then separating that out by location. So the different neighborhoods across the 5 boroughs in New York. And it was just really, really painfully clear that the largest number of housing complaints were in the poorest neighborhoods. And that's kind of expected, right? Just things aren't being kept up as well. So you have more complaints for housing problems. The problem that we found, though, is that the time it took for the state of New York to come in and actually fix those problems was significantly longer in poor neighborhoods as it was in rich neighborhoods, sometimes by a factor of like 3 to 5x. So you're talking about someone having a housing complaint in the middle of the winter that their heat isn't working, and the average response time in the richest neighborhood might be like 2 days, and in the poorest, it got it to like 30 days. So like really kind of dark, dark stuff like that. And so I really enjoyed the project for that reason.
All right, so I'll talk about the semester courses that Holden and I are currently taking. So both of us are in our 4th semester. So our 2 primary classes right now are Bayesian machine learning and practice and application of data science, which has been moved as noted next to each course. And I would say that practice and application is a very good course because it like it says, it's application, right? So you're getting a hands-on experience and like actually applying these different like data science methods. So that one's been a really fun class, and I mean, I've learned so much from it and how to like further apply concepts that you like briefly mentioned in other courses. And then Bayesian machine learning has definitely been a tougher course. If you don't have like a very strong like statistical theoretical math background, it's something that you have to learn how to really understand, but it is doable. And then finally, we have the capstone, which is it's staying in the 4th and 5th semesters, but it's probably the best part so far. So I'm getting to work for Phil Bourne's lab. So he's the dean of the School of Data Science, and I'm doing research regarding COVID variants. But it's a learning experience for sure. But I know Holden can speak to his because he's doing a different project.
Yeah, definitely. I think Chelsea summarized it well. Bayesian is very difficult, but really, really interesting. And it pairs well with the capstone projects that we're doing, where when you're working with your capstone companies, they have you working on like a certain set of objectives and deliverables that they want, which is great because you're helping out a company that's under-resourced and understaffed. But then on the side, in the Bayesian class, you also get to work on some of the same data sets that you're working on in the capstone, but taking a different bent, right? So trying to figure out how you can apply, difficult probabilistic models with uncertainty to the data set that you're working on in the capstone. And I've really enjoyed seeing things through that perspective. I think it's a good way to pair the capstone and some of the actual classwork that we're doing.
Well, then what's your capstone on?
So my capstone is awesome. I am working with a policy group called the LAJC that has committed itself to changing some of the pretty antiquated laws around criminal record history in the state of Virginia. So as it currently stands, anyone's record is searchable online, and it's really hard to get records expunged. So if you committed a crime 15 years ago in Virginia, like that's still there, and that disadvantages certain races and certain demographics in the population, and that needs to change. So the LAJC is actively working to change policy on that, and the work that we're doing is helping implement 2 things. One, an automated way of helping expungement, so actually getting people's records expunged in an automated way. And on the other hand, creating interesting visualizations that will help senators and actually help push policy forward by actually elucidating like just how disparaging some of these laws currently are.
So, the sense that you get from listening to Holden and Chelsea is these projects are really exciting. They're fun. And there's a chance for you to find one that you're passionate about, not just necessarily required for a course. So that's something that's really unique about our program. I'm going to go a little bit quickly through these career services and outcomes because this information is on our website. And we can talk a bit more about it in the Q&A, but I want to give a chance for everyone to ask questions that they have and take advantage of, having faculty members and student ambassadors on the call. So we do have 2 dedicated career counselors. They're really awesome. Reggie Leonard and Myra Khan Blanchard. They provide one-on-one appointments. That's advising, interview prep, resume or resume review. They provide resources, access to things like an alumni database, job postings, workshops, networking events. And we also just launched an industry advisor network that has over 20 advisors in the data science industry, and they offer career and professional development workshops, as well as one-on-one advising meetings. And this is a range of advisors across government, across industry. They're in companies that are startups, as well as like super large companies you might know about that are Fortune 300 companies. And they span insurance, technology, finance, healthcare, beyond. It's a great group of really dedicated advisors who are passionate about helping you get where you want to go with your career, and being there as a resource for you. So here are some outcomes for our class of 2020. Average starting salary, employment rate, and other things. Students, receive roles like these, and they're working in companies like Amazon, Capital One, Inference, Facebook, Booz Allen Hamilton, Deloitte, Ford Motor Company, UVA School of Medicine, Virginia Department of Transportation, Federal Reserve, and really what you can get the sense of from this slide is that people work across industry who come out of our program, just like people who come into our program are across different backgrounds. So the entry point is broad and the exit point's broad. So you can kind of go into really any industry, or path next educational opportunity where data is prevalent and important, but it's really broad and up to your interests. So some supports available to all students. We offer free tutoring. We offer group study sessions, faculty and TA office hours. Our faculty are really awesome. The ambassadors can speak more to that too if you have specific questions about faculty members, but they're really great and they're here for you. They want to help you succeed, and really rely on them, use them for support. And then also we have, access to the Student Disability Access Center for anyone who has a disability or some form of accommodation and needs support. We offer that for students as well.